I'm Meredith Patterson, and in these tutorials I'm going to teach you how to write more reliable, more secure software using some simple ideas about parsing and a library I wrote called Hammer. We designed Hammer because we want to make you a better programmer. We want to make it easier for you to understand and communicate about the logic that makes your programs run. And we found that when we organize software in terms of what input it takes, how it processes that input, and how it outputs its results, it's a lot simpler to reason about. This also saves you time because when it's easy for you to explain the properties of your program, it becomes faster to modify or debug. And as a bonus, the programs you write will have fewer bugs to begin with, so you won't lose time having to go back and fix problems that crop up. But what is Hammer? Well, it's a parser combinator library, and now you know exactly as much as you did before I told you that. So let's unpack that. Kind of like it sounds, parser combinators are things you use to combine parsers. Hammer is a software library that gives you a bunch of tools for combining parsers. And when you need to handle some input and make sure that only the input you want comes through, you can start from the simplest building blocks of what that input should be, then build up a complete description in software that's both easy for you as a developer to understand and straightforward to use as a discrete building block for the rest of your code. At the end of this course, you won't just have a working understanding of how to use Hammer and design software that takes advantage of it. You'll also have a working, lightweight implementation of JSON RPC over HTTP that you can then expand on in any direction you can imagine. You'll also be able to explain the benefits of designing software as a composed system of state machines, explain how bad input handling drives software exploitation and how formally reasoning about input handling can eliminate entire classes of vulnerabilities. You'll be able to produce a formal grammar describing a protocol or a message format, like from an RFC or from another specification, in parsing expression grammar notation. You'll be able to develop an input handling component as a concrete implementation of a parsing expression grammar using Hammer, including unit tests. You'll be able to develop the application layer interface between an input handling component and the rest of a program's logic. Think of this as an application internal API, because really that's what it is. And you'll be able to determine empirically using built-in benchmarking functions which parsing backend to use in production. This tutorial is completely online and at your own pace. Every video focuses on just one or two concepts. I might go through a coding exercise, talk about strategies we use to map our way from user stories to working code, or demonstrate some known vulnerabilities that have affected the protocols we're implementing, along with how Hammer eliminates these vulnerabilities by design. At the end of each video, I'll give you some exercises for you to try out on your own time, or point you at some reading material to get you thinking ahead about what we'll be discussing or doing in the next segment. Some of the reading exercises will be a lot of fun, but some of them, like RFCs, may also be pretty long and dry. It's okay to think of RFCs as more like reference materials, something you don't necessarily sit down and read straight through in one shot like you would an article. But it's smart to become really familiar with the way RFCs are laid out, because you're going to be referring to them a lot, and you'll be more effective at what you're doing if you know how to find your way around in them. Don't worry, we'll get into that more as we start working with RFCs in this module. To do the coding exercises, you're going to need a computer and a working C toolchain. A Linux system with GCC is just fine, and in fact, I'll demonstrate all the examples in this tutorial on a Debian box. OS X is fine as well. You're just going to want a package manager like Homebrew or MacPorts in order to install some of the dependencies. Our build system, Scons, uses Python, so you'll also need Python installed. And finally, our source code repository is on GitHub, so you'll also need Git in order to get the code to build it in the first place. If you're on Windows, you're going to need to do this tutorial in a virtual machine for now. We're sorry about that. You might also want to have a sketchpad or a whiteboard or something else you can draw on. In the next lesson, we're going to be talking about state machines, and there are two articles for you to read beforehand, both by Zed Shaw. The first one is called A Painless Introduction to Finite State Machines, and the second is called Ragal State Charts. Pay particular attention to the relationship between event-driven design and how events drive state machines, because that's going to guide how we design entire applications in a cleanly composable way. We'll also talk more about what composition is and what its implications are in the next lesson as well. See you then.